Alright, so today we're going to have a look at the double angle identities, and these are some special equations that will help us simplify our trigonometric functions that we've been looking at. Alright, so these are them. We have one for sine 2x, one for cosine 2x, and for tan 2x. And actually we've got three for cosine 2x, and we're going to see how these are used. So just before we get started, I'd like you to copy these ones down because these are what we're going to be referring to from now on in this next little section. And if you did want to break them up, we have the sine 2x. So we've just got one for sine 2x. For cosine 2x, we've got these three. And for tan 2x, we've got this one here as well. So each one of these is going to be really important going forward. All right, so let's have a look at a question. So given that sine alpha equals 3 on 5 and cosine alpha equals negative 4 on 5, we've been asked to find cosine of 2 alpha. Now when we see something like this, we can just go back to our previous formula. And what we can see from there is, I'll show you in a second, but cosine of 2 alpha equals cosine squared of alpha minus sine squared of alpha. All right, so we can see that that's our first one here. Now we could use any of these, but I've just chosen to use this first one, and you can try with the other ones and they will come up to be the same, but we're going to use this first one here. Now what I know is, I know what sine alpha is and cosine alpha is, and I can just substitute that straight in here. So I didn't know before, but now I can. So it's going to become cosine, which is negative 4 over 5 all squared, minus sine, which is 3 over 5 all squared. So we get 4 squared is 16, negative 4 squared is 16, and over 25, minus 9 over 25. All right, 16 minus 9 is 7 over 25, and that's our answer there. So you can see we've gone from something that we didn't know, using what we've been given, and we've come up with an answer, 7 over 25. Okay, so let's have another look at another type of question here. We've been given sine alpha, and we've been asked to find tan of 2 alpha. So we know that tan is sine over cosine. So the first thing we're going to do is we're going to find out what cosine is. And the way we're going to do that is we're going to use our old friend sine squared alpha plus cosine squared alpha equals 1. Now we know sine, so I can chuck that in, 5 over 13. Oh, that's a 13, all squared, plus cosine squared alpha, we don't know what that is, equals 1. Now if I square this side, I'm going to get 25 over 169 equals, plus cosine squared alpha equals 1. Therefore, cosine squared alpha equals 1 minus 25 over 169, which is the same as 169 over 169 minus 25 over 169. And that's going to give me 144 over 169. But we know that's cosine squared, so therefore, if I just want to get cosine by itself, cosine of alpha, I have to take the square root of 144 over 169, which equals plus or minus 12 over 13. All right. Now, we've got plus or minus here, but we've also been given this form here, which is our alpha lies between pi. So we know pi is here if we have our quadrant, and between pi on 2 and pi. So we're going to lie in this quadrant. And we can remember we've got that all silly turtles crawl, which means in our quadrant only sine is positive, which means cosine has to be negative. So therefore cosine alpha equals negative 12 over 13 in our quadrant. All right, so we've done all that work to find out what cosine is. So I've just cleaned up the page here. We also know that tan of alpha equals sine of alpha divided by cosine of alpha. All right, so we've got sine of alpha and we've got cosine of alpha. So it's going to be 5 over 13 divided by 12 over 13. Sorry, negative 12 over 13, which is going to give me, my 13 is going to cancel and I'm going to end up with negative 5 over 12 for my tan alpha, which can be useful for our identity. So the identity we're going to use, because we've been asked to find tan 2 alpha, is that last one. So tan 2 alpha equals 2 tan x over 1 minus tan squared x. So let's put that in. Okay, so here's the identity. Now we're going to do 2 times tan x. Now we've just worked out, or alpha, doesn't matter. In our case, it's negative 5 over 12. So 2 times negative 5 over 12 divided by 1 minus tan squared. So negative 5 over 12 all squared. Now if I just multiply across, I end up with, on the top row, negative 10 over 12. And on the bottom row, 1 minus 25 over 144. Now, we could solve this step by step, but I'm just going to save a little bit of time and put it in the calculator. We end up with negative 120 over 119. And that's the answer to our question here, so tan 2x, from what we were given. So it's a bit of a lengthy process, but we used what we were given and some previous knowledge as well. All right, so use an appropriate double angle identity to simplify 4 cosine squared 2 beta minus 2. So whenever we see something like this, what we want to do is we want to go back to our double angle formulas and look for something that looks pretty similar. So 4 cosine squared 2 beta minus 2. Now it doesn't look anything like the first one. It doesn't look anything like this one. It does kind of look like cosine squared minus something, so it kind of looks like that. No, it doesn't look like that one. It doesn't look. So it's going to look like this. So what we want to do is rearrange so we can see it in this form. So what we need to do is rearrange it so it looks like cosine squared minus 1, 2 cosine squared minus 1. And we can actually do that by removing a factor of 2 out of both of these things. So if I remove a factor of 2, I'm going to be left with 2 times 2 is 4. 2 cosine squared 2 beta minus 2. Sorry, 2 times negative 1. All right, so that's going to be minus 1. Okay, so now what we've got is 2 cosine squared 2 beta minus 1. If we go back to our formula, that's exactly what it looks like. And that thing is equal to 2 times x. Now, the trick with ours is we've already got 2 here. We've already got a 2 with our 2 beta, but that's okay because we know that this is going to be, this part here is going to simplify to cosine of 2 lots of the angle, which is 2 beta. And we've got to times that whole thing by 2. All right, 2 times that, it just becomes 2 cosine. 2 times 2 beta is 4 beta. And that's what we're left with. And that's how we simplify it. Okay, so there's heaps of ways to do this. I can't show you an example about every one, but we can use those techniques to simplify and solve a lot of problems. Okay, thank you.